Hi, welcome back to Calculus. Today we're going to be looking at derivatives of inverses and logarithms. This is section 3.8 in our calculus book. So I wanted to start with a graph here of a function and its inverse because we're going to kind of pick that apart and we're going to think about a little, what it means to be an inverse just a little bit, and then we'll jump in and see how we take the derivative of an inverse. And that's going to be super useful because we don't know how to do derivatives of logarithms yet. But once we can do inverses, we will be able to, and we'll see that a little bit later in the video. So for starters, here's my function f, and let's consider a point on that graph where the x value is a and the y value is b, right? Inputs and outputs. Now what we know about inverses, or what we can simply say about them, is that they are a reflection across the line y equal to x. Okay, so I have that dotted line in here, and then I have the inverse graph. And what happens when you take an inverse is that all the ordered pairs switch places. So what was x becomes y, and what was y becomes x. They just switch. And so when we switch the x's and y's, if you think about what we're really doing here with derivatives, we're finding the slope of the curve. In particular at the points that I've marked here. But what is slope? Slope is y over x. So if we switch the x's and x and y coordinates, all we're really doing for the slope is we're flipping it upside down. We're making a reciprocal. And that's really going to be how we're going to think about derivatives for inverses. So let's move over here and take a look. The derivative of the inverse function of f at a point b is equal to 1 over, there's that reciprocal, 1 over the derivative of the function f evaluated at the inverse of b. So if you have a y value b, the x value, this is basically the x value that would have given you that y value. And so we can take derivatives of an inverse function just by doing the reciprocal of the original function at that inverse value. And so I have a second way to write it here. The derivative of f inverse with respect to x, evaluated at x equals b, is equal to 1 over the derivative of the original function, evaluated at x equal to the inverse, f inverse of b. So we'll go ahead and do an example of that, and then we'll move into logarithms, and that'll be kind of fun. So let's do that. All right, so let's go ahead and do this example. We're going to let f of x be x cubed minus 2, and we want to find the derivative of the inverse at x equal to 6, which is equal to f of 2, without finding a formula for f inverse. Sorry about that. All right, one important thing here. This x equals 6, this is referring to the inverse function. So for the original function, that's a y value. That's why we have f of 2 here. That's actually the x value for the original function. Okay, so the ordered pair here for the original function would be 2, 6. For the inverse, it's 6, 2. All right. So to do this, we're just going to first take the derivative of f. Well, the derivative of f, that's not too bad. We drop the 3 down front, so we get 3x squared. The 2 obviously goes away, becomes 0. And then we can plug in the 2. Again, be careful. We're working with the original function here, not the inverse, so we want that 2. So if we plug in 2, we get 12. And then from our definition, that just means that the derivative of the inverse at 6 is equal to 1 over the derivative of f at 2, which gives us 1/12. And that's it. All right, let's move into logarithms. All right, so to start logarithms, we're going to look at natural log first, and we're going to show you where this derivative comes from. And it's going to come straight out of the work that we just looked at with the inverses. So let's start with f of x being e to the x. We know that derivative, so we can work without it just fine. The inverse function for e to the x is natural log of x. Remember, an exponential function and a logarithmic function with the same base are inverses of each other. So what that means is the derivative, because this is the one we're really wanting to get, the derivative of my inverse function of x is equal to 1 over the derivative of f evaluated at f inverse of x. Now that's a little bit messy, but let's clean this up. We know what f inverse of x is. It's just the natural log. So now I have 1 over f prime of the natural log of x. Well, hold on. Oh, The derivative of, yeah, just lost my brain for a second. The derivative of e to the x is just e to the x, but since we've got natural log on the inside, we get e to the natural log of x. So it's kind of messy, but here's the really important bit. Now that we're here, e to the power and natural log of x are inverses of each other, which means they get rid of each other, just leaving the x. So all of that to say that the derivative with respect to x of the natural log of x is equal to 1 over x. Okay, so it's kind of a mess walking through there a little bit, but it works out pretty nice. You just get 1 over x. To make it a little bit more generic, if u is a function of x, then the derivative with respect to x of the natural log of u is 1 over u, so whatever's on the inside, times the derivative of that inside. There's the chain rule that we just looked at a couple sections ago. All right, so let's do a couple of examples and let's see where this takes us. All right, so here's an example using the chain rule on a natural log. I have the natural log of x to the fourth minus 7x. So you can see I identified the parentheses here as my u. That's that little function of x. And so I took the derivative of that first. So I dropped the 4 down, giving me 4x cubed. And then minus 7, the x goes away. And so then I can piece together this derivative. I know that the derivative of natural log is 1 over u. So here's u, that x to the fourth minus 7x. And then times, here's du dx, right? The derivative of the log times the derivative of the inside. So then I just, pretended this was over 1, put my fraction back together, and we have our answer, 4x cubed minus 7 over x to the fourth minus 7x. All right, let's look at some more generic exponential functions and logarithmic functions. So we've done e to the x, we've done natural log x. Let's look at a to the x. All right, so let's look at a to the x. We want to try and figure out its derivative. You can see I have it all here, but let's walk through it. So to start, we're going to have to cheat just a little bit. We don't know anything about a to the x as of yet. We will in just a minute. So I'm going to use the fact that e to the x and natural log of x are inverses of each other. So that means that a to the x then is the same as e to the natural log of a to the x. Again, because the e and the natural log would cancel each other out, being inverses. So then what I can do is I can use the properties of logarithms to drop this x in front of the natural log. So a to the x is the same as e to the x times the natural log of a. You're all like, yay, thanks, that's super. Well, it really is, because now we can take its derivative. Okay, we're going to change the a to the x to e to the x natural log of a. And all this is going to be a chain rule. Natural log of a is just a number. We know how to do the derivative of e to the 2x, so we know how to do e to the x times the natural log of a. We know the derivative of e to the anything is just e to the anything, and then times the derivative on the inside. But since my inside is just a constant times x, the derivative of that inside piece is just the natural log of a. So we get e to the x natural log of a times the natural log of a, but that simplifies because we've seen that before. That was way back up here, right? E to the x natural log of a is just a to the x. So long story short, if you want the derivative of a to the x, it's just a to the x times the natural log of the base. And that's it. So an example with just with 3 to the x, a really simple one. The derivative with respect to x of 3 to the x is 3 to the x times the natural log of 3. That's not so bad. And this one's certainly messier. The derivative with respect to x of 2 to the negative cosine x, well, it's going to be 2 to the power times the natural log of 2, that base. But this one has a chain rule, so we need the derivative of that negative cosine. But we know the derivative of cosine is negative sine, so that means the derivative of negative cosine is positive sine. And there we go. There's the derivative for this big mess. 2 to the negative cosine x times the natural log of 2 times the sine of x. Lots of fun. All right, I have one more short little thing that we have to go through, and then we've got kind of a big messy thing. So hang on. All right, the last little thing I'm going to put on this video, and then we'll do the rest of the section on another video, is I want the derivative of the log of some random base a. Okay, so not the natural log this time, just base a. So to do that, we're going to change the base. We know the derivative of natural log, so we're going to use the change of base formula that hopefully you learned somewhere along the line. If you had me, you did. And so what we know is that log base a of x is the same as the natural log of x over the natural log of that base. And so now we can take this derivative because we know the derivative of natural log. But before I do, I want to just kind of note, natural log of a, that's just a number. Okay, if you have base 2, this would be the natural log of 2. You could plug that in your calculator and get some kind of nasty looking number out of it. So I just dragged that constant out front. Remember, we can always do that. We know that the derivative of a constant times a function is just the constant times the derivative of the function. So I dragged that constant out front. Please keep it on the bottom, that'd be important. And the derivative of natural log then is just 1 over x. So I get 1 over the natural log of a times 1 over x, and I put it back together because it's just multiplying fractions. I put the x in front because it's a little bit cleaner that way, but keep in mind, natural log of a here, it's going to be a number. All right, so in the next video, we're going to look at logarithmic differentiation. This will still be the same section in the book, but it's kind of messy, so we're going to put it in its own video.